Yes, I want to take you through solubility of a solute. This is a topic in Form 4, acids and bases, and we have solubility curves, solubility and solubility curves. But I want to emphasize on the mathematics part of it, and I want to start from the basics that made even myself when I was in high school. I could not understand this subtopic of solubility of a solute because I did not understand the basics. So first, there are things I want you to understand before you get into the details of solubility. First, you should know how to define solubility of a solute. What is solubility of a solute? So, solubility of a solute, this is the mass of a solute that will dissolve in 100 grams of a solvent to form a saturated solution at a given temperature. That is correct. But the question is, do you understand what is a saturated solution? Do you know what is a solvent? Do you know what is a solute? That's where the game kicked me out when I was in high school. But now, I know better. For us to understand solubility, let us define these terms. What is a solute? A solute. A solute is a substance that dissolves in a solvent to produce a homogeneous mixture. Even if you stop it at here, that dissolve in a solvent, leave the rest. So a solute is a substance which dissolves in a solvent. And then what is a solvent? A solvent is a solution, is a liquid, let me call it as liquid, or a substance in which a solute dissolves. That is very correct. So when a solute dissolves in a solvent, the product is a solution. So what is a solution? A solution must contain a solute plus a solvent. Let me take an example of a solvent water. This is the common solvent we are using. A solute. Solutes, we have so many solutes. Take sodium chloride. This is a salt and it is a solute. So when you dissolve sodium chloride in water, this is a solute plus a solvent, you form a solution of sodium chloride, right? What you form is sodium chloride, and that is a solution. Now, when you understand that one, you are going to find the solubility calculations very, very easy to tackle. Another word I want you to get is a saturated solution. What is a saturated solution? A saturated solution is a solution in which no more solute can dissolve at that temperature. It is a solution in which no more solute can dissolve. That solution in which no more of the solute can dissolve in that particular temperature is called a saturated solution. A saturated solution is a solution that contains the maximum amount of the solute. Maximum. If something has a maximum amount, it means it can no longer take more. Maximum amount of the solute that can be dissolved under the conditions at which the solution exists. If it is existing at 25 degrees Celsius and the maximum solute has dissolved in that solution, it will stop. It will not dissolve any more of the solute. The solute you are going to add will remain at the bottom of the solution. I hope you understand that. So I will demonstrate something for you here, and then you will see. Now with me here, I have zinc sulfate. This is the salt. This is what we call the solute. So This one is the solute. So if I put it here, so what I have here is the solute. I have distilled water here. You can see distilled water. So let me put the distilled water in a beaker. So distilled water is the solvent in this case, because the most common solvent that is used is water. So now when I add the solute into the solvent, I add the salt to the solvent, solute to the solvent, and then stir. I stir. Until the solid dissolves. The solute dissolves. Now the solute has dissolved. Now I have a solution. So what is a solution? A solution is a combination of a solute and a solvent. Right? Very good. Having understood what is a saturated solution, having known what is a solvent, having known what is a solute, now we can comfortably define solubility of a solute. Now let me take you slowly what is solubility of a solute. This is the mass of a solute that will dissolve in 100 grams of the solvent. I have said the solvent mostly we use is water to form a saturated solution at a given temperature. So if I have 50 grams dissolved in 100 grams of water, 100 grams of water, this is what we call solubility of that solute to form a saturated solution. So it is the mass of a solute that will dissolve in 100 grams of water to form a saturated solution at a given temperature. Very important, because solubility depends on temperature. When you vary temperature, when you change temperature, the solubility changes. Mark that. So whenever you are asked to calculate solubility of a salt, if you are told calculate the solubility of a salt, you are simply asked to calculate the mass in grams, in the mass in 100 centimeters cube of water. Calculate the solubility. The solubility exists in 100 grams of a solvent. So I will take you straight to examples, because when we do examples, you will be able to understand more than the theorem I'm talking about. Example 1. A mass of 56 grams of a saturated solution of a salt K at 25 degrees Celsius yielded 14 grams of a solid when evaporated to dryness. What is the solubility of the salt in 25 degrees Celsius? What is the solubility of the salt in 25 degrees Celsius? So remember, now we have 56 of a saturated solution. But what is a saturated solution? What is the content of a saturated solution? Remember, saturated solution equal to a solvent plus a solute. There is a certain amount of solute dissolved in a solvent to form a saturated solution. Very important. But now the saturated solution is 56 grams. The solvent, and we are told that it yielded 14 grams. So the mass of the solute that was dissolved in a certain in a certain amount of water, taking an example of water as a solvent, 14 was dissolved in that water. So solvent, we don't have the solvent, but we have the solute, 14 grams. But we can easily get the volume or the mass of the solute by doing this simple math. So what we do, we will take this one this side, that's 56, minus 14 will give us the solvent. So solvent equal to 56 minus that is 42 grams of, if it was water, it is water. Because most the common, I am using water because water is the common solvent we use in the laboratory. I'm saying the common. We have other solvents, but this is commonly used. Next, now we have that 14 grams of the solute was dissolved in 42 grams of water to form a saturated solution, which is 56 grams. Now the question is, what is the solubility? Solubility, like we have defined it, solubility is the mass in 100 grams of water. But we have a certain mass in 42 grams. Now we are going to ask, what about 100 grams of water? And that is the solubility. So we know that 42 grams of water was dissolved in 14 grams of the solute. 100 grams of water will contain what amount of the solute? It is 100 times 14 divided by 42, and it will give us 33.33 grams per 100 grams of water. And that is the solubility. There is a formula also you can use. Solubility equal to mass of the solute times 100 divided by mass of the solvent. So you must find the mass of the solvent. You must have the mass of the solute times 100 and then get the solubility. In this case, the mass of the solute was 14 times 100. The mass of the solvent was 42, solvent 42. And that one will give you 3.33 grams per 100 grams of water. State one precaution that could be taken during the experiment above. When you are drying to get crystals to dryness, it is important to use a water bath. So the precaution is that use a water bath during evaporation. Why do we use the water bath? It is to prevent spouting out of the salt. To prevent spouting out of the salt. Spouting out is the way it when it forms crystals, it will start jumping out. That is what we call spouting out. It will jump out. Therefore, we call it spouting out of the salt. So that's the precaution. Let us go to another question 2. Calculate the solubility of potassium nitrate if 5 grams of the salt is dissolved in 40 centimeters cube of water. You have been given the density of water is 1 gram by this. What that is important, but you should know that 40 centimeters cube of water is the same as 40 grams of water is the same as 40 milliliter of water. So this is the same thing. We are talking about the same thing. Now maybe somebody is wondering how can 40 centimeters cube be 40 grams? This is how. You know that the density is equal to mass over volume. Now the density of water is 1. Put 1 there, which is 1 gram over centimeters cube, equal to mass. We don't have the mass over volume, which is 40. Right? Now we want to calculate this is centimeters cube. So cross multiply this. You multiply that, you will get that 40 grams is equal to mass. So the mass is 40 what? 40 grams. So 40 centimeters cube is the same as 40 grams, is the same as 40 ml. Now we want to calculate the solubility. We are told that this volume contains 5 grams of the salt. Calculate the solubility. Solubility is the mass of a solute required to dissolve 100 grams of the solvent to form a saturated solution. Very important to understand the definition. Therefore, we will ask 40 grams of the solvent, that is water, we have been given of water, will dissolve 5 grams of the solute. What will 100 grams of water contain? Because solubility is the mass that is needed to dissolve 100 grams of water to form a saturated solution. So this is 100 times 5 divided by 40, and this one will give us 12.5 grams or stroke 100 grams of water, and that is the solubility. So 100 grams of water requires 12.5 grams to make a saturated solution at a given temperature. We are not given the temperature, at a given temperature. Solubility of salt X at 20 degrees Celsius is 40 grams 100 of water, while at 70 degrees Celsius is this. Determine the mass of the salt that will crystallize out when 165 of a saturated solution is cooled from 70 to 20. It is supposed to be 20 to 20 degrees Celsius. So we must understand at what? At 70 degrees Celsius, what is the solubility? At 70, it is 65 grams in 100 grams of water. At 20 degrees Celsius, at 20, it is 40 grams of 100 grams of water. Yes? So, but remember, we have now here a saturated solution. This saturated solution contains a given volume of a solvent or a mass, and it contains a solute. So from the way this is 165, it means it was dissolved in 100 grams of water, and 65 grams of the solute was dissolved in 100 grams. So that's what it means. So it means 165, it is important to understand, grams of saturated solution implies that 65 grams was dissolved in 100 grams of water. So that 65 plus this one, the answer is 165 grams. 65 grams. Are we together? I hope so. So now it means that we have 65 grams of the solute dissolved in 100 grams of water. Now we want to know the crystals that will be formed when the solution is cooled from 70 to 20. But we know the solubility at 20 is 40, right? The solubility at 20 degrees Celsius is 40. And the mass now, the final temperature is 65. We have our mass at being cooled to 20. Our mass is of the mixture is now 65 grams. What will be the mass that will crystallize out? Because this one is going to 20 degrees Celsius, and the 20 degrees Celsius is 40 grams. The solubility at 20 degrees is 40 grams in 100. Now we have the solubility to be in 20, 65. Now it is more than what is there. Therefore, it means the excess, the mass that is above 40 will form crystals. Right? Now the crystals now is 65 minus 40. We will have 25 grams of crystals are going to be formed. The mass of a solution T is 120 grams. This solution has 80 grams of the salt T dissolved in it. The solubility of this salt is 25 grams per 100 grams of water at 40 degrees Celsius. Full stop. 55 of salt T, 55 grams. 55 grams of salt T was added to the solution at 40 degrees Celsius. Calculated the amount of salt T that remained undissolved. So first, we start from solution T, a solution. You understand that a solution contains of a solvent plus a solute. So the solution is 120. This solution has 80 grams of the solidity. So already this solution contains 80 grams of the solute. So we have the solute of 8. Now the solvent, we don't know, plus 8 grams. Now we can get the solvent by itself. So that is solvent equal to 120 minus 8. And that is 112 grams of water. Very good. So we have 112 grams of the solvent. But we are told that the solubility of this salt is 25 grams per 100 grams of water at 40. So the next thing we are going to ask, we know that 25 grams of the solute, that is the solubility, contains 100 grams of water. First, we want to know our solvent. What will be the total mass contained in this volume? So 112 grams of water, this will contain what mass? So we have 112 times 25 divided by 100, and this one is going to give us 28 grams. So this solution requires 28 grams to be saturated. This solvent, this water here, requires 28 grams to be saturated. The question continues and says that 55 of salt T was added to the solution. Remember, our solution contains, this 120 grams contains only 8 grams, and the total required is 28 grams. But this person now is adding 55 grams of the salt T was added to the solution at 40 degrees. Calculated the amount of salt T that remained unsolved. This is our total mass of the solute that is required to have a saturated solution. But already we have 80 grams in the solution. So therefore, 28 grams minus 8, we want 20 grams to make our solution saturated. We want 20 grams to make our solution saturated. So 20 grams are required. We don't need 55. We only need 20 because already 8 is there. The total mass we need to get our solution saturated is 28. We already have 8 grams in the solution. The remaining amount is 20. But this person is adding 55 grams of salt T. What salt will remain? What amount of salt will remain undissolved? So 55 minus 20, we will have 35 grams of T remaining undissolved. That remain. The table below shows the solubility of potassium bromide and the potassium sulfate at 0 degrees and 40 degrees. Solubility, the substance. Now, at 0 degrees, the solubility of sodium bromide is 55. At 40 is 75. Potassium sulfate is 10 and 22 at 40 degrees Celsius. Now, before we move, let me show you how to understand this table. At 0 degrees, this solution, potassium bromide requires 55 grams to form a saturated solution at 0 degrees. So, if you have a solution which has more mass, like 56, 57, that solution will form crystals, because you have gone beyond. Because a saturated solution, it cannot dissolve the excess, the extra. It will not dissolve. It will form crystals. But if we have 54 grams, 52 less than 55, that solution is not saturated. It will not form crystals. The salt will remain in solution. It will not form crystals. Potassium sulfate. If I have 12 here, potassium sulfate will form crystals. Why? Because at 0 degrees, it requires only 10 grams. It will require 10 grams to form a saturated solution. Any more solute will remain as crystals, will form crystals. If the solute is less, 9, 8, the solute will remain in solution because it has not reached saturation point. So let us now go to the question. When an aqueous mixture containing 60 grams of potassium bromide and 7 of potassium sulfate is in 100 grams of water was cooled to 0 degrees, some crystals were formed. Identify the crystals. The most important is the final. We consider the final temperature. Now, these two salts are being cooled from 80 to 0. So now we go to 0. That's where we are. This one was 60 grams potassium bromide. So they put 60 grams. So putting 60 grams, 60 grams means that it is more. Therefore, it will form crystals. It is more than 55, it will form crystals. Let us look at this one. They put 7 grams. 7 grams is less than 10. It means that this salt will remain in solution. It will not form crystals. It will remain in solution and it will not form crystals. Now, which salt will form crystals? It is potassium bromide. Potassium bromide. Determine the mass of these crystals. The mass of the crystals, what we have is 60. The required for solubility is 55. So the excess is 5 grams and this will be crystals. Solubility is 55. We have 60. Therefore, the excess will form crystals because the solubility is 55. Name the method used to obtain the crystals. The method is fractional. Crystallization. I will take you through more examples of the same so that you can get the point clear. We have another table that's similar to that. The table below shows the solubility of lead 2 nitrate and copper 2 sulfate. Use it to answer the question. Solubility at 40, at 60. The table below shows the us the solubility of lead 2 nitrate and copper 2 sulfate. Use it to answer the questions that follow. When an aqueous mixture containing 35 and 78 in 100 grams of water at 80 was cooled to 40 degrees Celsius, some crystals were formed. Which salt crystallized out? So before you find out which crystal, you need to understand this, what is happening. At 40 copper sulfate, the saturated solution at 40 degrees Celsius is 28. Lead of that is of copper 2 sulfate. What about lead nitrate? It is 79. Now, we are not interested from where it came from. We are interested to the final temperature where it is going to form crystals. Our final temperature is 40. So we consider this temperature. We have 35 grams of copper 2 sulfate. Here we have 35. We have 78, right? Now 78, 79. Lead nitrate requires 79 grams to be saturated. That is the solubility, right? Now, if it is 78, it means it has not yet even reached 79. Therefore, 78 grams will not form a saturated solution. First thing, if it will not form a saturated solution at 78, it is still in a solution. Will it form crystals? It will not. Let us consider copper sulfate. Copper sulfate requires, at 40 degrees, requires 28 grams to form a saturated solution. So if you add anything more than 28, whatever is more is the crystal. It will form crystals. So if I have 29, we will have 1 gram crystal. 30, we will have 2 grams crystals. But if we have anything less, 27, it will not form crystals because it requires 28. Now we have 35. Will it form crystals? Yes, it will form crystals. 78, 79. It requires 79. We have 78. It will not form crystals. So which salt crystallizes out? Copper 2 sulfate. Copper 2 sulfate is the one that formed the crystals. What is the reason? Because the solubility, it is because the solubility at 40 degrees Celsius is 28 grams and the mass dissolved is 35 grams, which is more than 28 grams, hence forms crystals. Calculated the mass of the crystals that was formed. The mass of the crystal that was formed, we have 35 grams minus 28 grams, and the answer is 7. Yeah, 7 grams. 7 grams of crystals will be formed. 7 grams. Last example of the same. The table below shows the solubility of substances T and U at 10 degrees Celsius and 40 degrees Celsius. TU at 10 degrees Celsius and 40 degrees Celsius. So T requires 40 grams to form a saturated solution in 10 degrees Celsius. U requires 15 So this one is 17, sorry. This one is supposed to be 17. U 15 grams will form a saturated solution in 100 grams of water at 10 degrees. So if you have anything more than 15 at 10 degrees Celsius, it will form crystals. But if you have anything less, the mass is less, it will not form crystals at 10 degrees Celsius. 40. At 10 degrees Celsius, 40 grams is required to form a saturated solution. If you have anything more than 40, it will form crystals. If you have mass that is less than 40, it will not form crystals. Understood? Thank you. So let us go to a question. When an aqueous mixture of containing 55 T, so T, we are having 55 grams, and 12 grams G, and 12 grams G, U, and 12 grams of U, was cooled to 10 degrees. So was cooled to 10 degrees. So I told you we consider the final temperature. We are cooling to where? To 10 to 40. That is why we are considering 10 degrees Celsius, the final temperature. Now, T, now we want to know which salt will form crystals. Identify the salt which will form crystals. U will not form crystals. X. Why? At 10 degrees it requires 15 grams. But we are having 12 grams of U. So it will not form it will not form crystals at 10 degrees Celsius. T forms crystals at the saturated solution of at 40. At 40 it forms a saturated solution, but we have more solute, 55. So it means at exactly 41, 42, 43, those are crystals up to 55. So identify the crystal. The crystal will be T. T will form crystals. Determine the mass of the crystals. The mass of the crystal, we have 55. 40 is required to form a saturated solution, minus 40. So it will give us 15 grams of saturated of crystals formed. Leave around this one. I want to do the final math here. The solubility of iron 2 sulfate at 22 degrees Celsius is this, this of water. Calculate the mass of iron 2 sulfate crystals of 45 grams of a saturated solution at the same temperature, 3 max. The solubility of iron 2 sulfate is 22 degree at 22 is this, very important. So we have the solubility at 22 degrees Celsius to be 15.65 in 100 centimeters cube of water. We wanted to calculate the mass of iron 2 sulfate crystals of 45 grams of a saturated solution. Very important. So we start at this point. We know that a saturated solution, is made up of a solvent plus a solute. That's one thing we know for sure. We have a saturated solution of 45 grams. This one. But we don't have the solute. We don't have the solvent. Right? We don't have the solvent plus the solute. We don't know. So let the mass of the solute be X. Right? Let the mass of the solute be X. So if the mass of the solute is X, now we will have 45 grams plus the solvent equal to equal to 45, which is the solution, equal to the solvent plus X. Can we get the mass of the solvent? Very good, X grams. Can we get the mass of the solvent? Very correct, we can get. So solvent equal to 45 grams minus X. We can put this one in grams. Now we have the mass of the solvent. You understand that? Very good. So don't worry about this. Now we have the mass of the solvent. We have the mass of the solute. We have the mass of the solution. But we know here that the solubility is 15 grams per 100 water. We know that. That's what one thing we know. So we know that 15.65 grams of the solute was required to form to dissolve in 100 grams of water to form a saturated solution. Now we will ask this solvent, if 15 this of the solute requires this water. This solvent, our solvent here is, now we can use water. This is water actually. So we will ask 45 minus X grams of water will contain how many grams of the solute? Now we will have 45 minus X grams times 15.65 divided by 100. This one equal to the mass of the solute that we need. But we said that let the mass of the solute be X. So it means that this mass will be equal to X. Because we have said that let the mass be X. If the mass is X, then it will be equal to this. So we multiply, we want to remove this one, this times this, and that we have 45 minus X times 15.65 equal to 100X. So we can open the bracket here, we will have 704.25. So 704.2.5. So what we are doing, this times this will give you 704.5, and then 15.65 times X, it will give you negative 15.65X, which is equal to 100X. So like terms together, this one will go there, 704.25 equal to 100. So this one we are going to add, we will have 115.65X. We want the value of X, we divide it by both sides by 115.65. So X equal to 6.089 grams, and that is the mass of the solute that was dissolved in the water to form the solution. Thank you very much. If you have any question that is giving you headache on solubility, you can text me on WhatsApp 726 46 89 15. Just send a text on WhatsApp, and then you can send it through WhatsApp. I don't charge anything. It is free. In an experiment to determine the solubility of solid Y in water at 30 degrees Celsius, the following results were obtained. Mass of empty evaporating dish is 26.2 grams. Mass of evaporating dish plus saturated solution is 42.4 grams. Mass of evaporating dish plus dry solid 30.4 grams. Use the data to calculate the solubility of Y at 30 degrees Celsius in grams of Y, and 30 degrees Celsius, grams of Y per 100 centimeters of water. So we want to calculate solubility. So first, we want to calculate the mass of saturated solution. The mass of saturated solution, but we have mass of saturated solution plus the dish is equal 42 volts. So how do we get the mass of the saturated solution alone? Is the total mass of the dish and the saturated solution subtract the mass of empty evaporating dish. So that one is 42.4 grams minus 26.2. So mass of saturated solution is 16.2 grams. Next one, we want to calculate the mass of the dry solid. Mass of dry solid. We have evaporating dish plus the dry solid is equal 30.4. But we know empty evaporating dish is 26.2. So we can get the mass of the dry solid. So this total subtract 26, we will get the mass of the solid alone. So that is 30.4 minus 26.2 empty evaporating dish, and it will give us 4.2 grams. Let me write here. So this minus this is giving us 4.2 grams. This is the mass of the solute, that is the solid. Right? Now we have the mass of the saturated solution, we have the mass of the solute. But we know a saturated solution equal to solute plus solvent. Yes. So this one we have as 16.2 grams. The solute we have 4.2 grams plus the solvent. We don't know the solvent, but now we can get the solvent by liking terms together. So solvent equal to 16.2 minus 4.2, which is the solid, and it is giving us 12 grams. 12 grams. This is now the solvent water. This is water. So 12 grams of water dissolved in 4.2 grams. Now we will ask 100 grams of water will dissolve what amount of the solute? That's what we call solubility. Now we will say that 12 grams of water dissolves 4.2 grams of the solute. 100 grams, because solubility is the mass in 100 grams to form a saturated solution. Water will contain what amount of the solute? 100 times 4.2 divided by 12. That one will give us 35 grams per 100 grams of water. So let me write it here, that this one will give us 35 grams in 100 grams of water. So that is the solubility. Thank you. It is from this place I am doing what I'm doing and what you are saying. My question is, why have you refused to subscribe? Does it cost anything? It is free. Please subscribe. Subscribe. That is the support you can give me. I don't need money from you. I need nothing. Just subscribe.